The whole point of at-risk simulation models is to see the distributions of selected at-risk outputs, given the distributions of uncertain inputs. For example, you might want to know the average profit, the standard deviation of profit, percentiles of profit, and the shape of the profit distribution. The power of at-risk is that it gives you access to such information in a variety of reports after a simulation has been run. You will undoubtedly choose your favorite at-risk reports for analyzing output distributions, but this video will explore the possibilities so that you can see the various options. There are a lot, and they are all found from the results group on the at-risk ribbon. As you can see, most of its buttons are disabled until a simulation is run. The example shown here will be used for illustration. It is adapted from one of the at-risk example files. A company is introducing a new product, and the model estimates the NPV of the cash flows from the product over a 10-year horizon. The cells in green font are uncertain input cells, and the cells in maroon font have been designated as at-risk outputs. Actually, each of the rows 19 to 22 has been designated as an at-risk output range. A key input to the model is whether a competitor enters the market at the beginning of year 1. This input is either 0 or 1, as shown in cell C7. And it is determined by the probability of entry in cell E7. The company would like to try 3 different values, 0.1, 0.5, and 0.9, for this probability of entry to see their effect on NPV. This is done with a risk sim table function in cell E7, and the number of simulations is set to 3. If you are not familiar with the risk sim table function, you might want to watch the video about it in the guided tour series. Before running the simulation, it helps to appreciate what this video is all about. If you toggle the at-risk dice button to random, that is orange, and repeatedly press the F9 recalc key, you see many different scenarios as the green input cells change and the maroon output cells change accordingly. The strength of at-risk is that it not only recalculates as many times as you like, 1,000, 5,000, 10,000, or however many iterations you choose, but it keeps track of the input and output values and then lets you see the results in a variety of ways. In short, at-risk is a great bookkeeper. When you run the simulation, you might or might not see a graph being built as the simulation runs. This depends on whether the automatically show output graph button is toggled to orange or white, this button. Right now it is toggled to orange, so you will see an output graph. If I toggle it to white, you wouldn't see it. You can run the simulation with both possibilities to see the effect. You might like the graph to appear automatically, or you might not. Showing the graph can actually slow down the simulation a little, so you might prefer to toggle the button to white. This is totally up to you. Now I will select the NPV cell and run the simulation with the button toggled to orange. You see the histogram of NPV being built. However, even after this window is closed, you can recover the graph at any time by selecting an output cell and clicking the at-risk Browse Results button. This might just become your favorite way to get quick interactive results. For example, here is the distribution of NPV for the first simulation, where the probability of entry is 0.1. Right here. I will move the 2 sliders so that you can see the probability of negative NPV, close to 1%, and the probability that NPV is greater than 1 million, about 36%. As you have probably noticed, this window shows the same type of information for an output distribution as the Defined Distributions window shows for an input distribution. You can experiment with the buttons at the bottom, Help, change graph options. This allows you to get a report in Excel or copy the graph and paste it into Excel or another document. This allows you to show different forms of the histogram, such as cumulative ascending or the density function. This allows you to show sensitivity analysis, which is discussed in a companion video in the guided tour series. This allows you to superimpose another output distribution. This is for scatter plots to see how this output is related to another output. This is for scenario analysis, discussed in another video in the guided tour series. I will show this one in just a minute, and this one. This is for defining a filter on what is shown in the histogram. This is for fitting distribution to data and for zooming in and out. For example, the red button with the pound sign lets you see the graph for any of the simulations. Here's for number 2. Here's for number 3. Alternatively, you can click the button to its left, select Summary Trend, and then highlight a range such as the net cash flow range for any one of the simulations or all of them to see this summary trend graph. This is particularly useful for time series outputs. Also, while this window is open, you can select any other output cell to see its distribution. That is, you don't have to close the window first and then reopen it. In fact, you can even select an input cell to see its distribution of simulated values. Of course, this should match the theoretical distribution, in this case triangular, that you entered for this input. Again, remember that these great browse results graphs are only a click away, but only after you have run a simulation. Another nice option is the Summary Report option. If you click the Summary button, you get a window with 2 tabs for inputs and outputs. You are probably most interested in the latter, shown here. It has 1 row for each output cell for each simulation. Each row contains a mini graph and several summary measures, and you can control which ones are shown. If you right-click anywhere in the middle of this window, you can choose which columns to graph. For example, I like median and standard deviation, and I unchecked another one called errors. You can also double-click any of the mini charts to get a full-size version. Finally, the buttons at the bottom lead to the same basic options as the buttons at the bottom of the Browse Results window. The Browse Results and Summary options open a window, but their results are temporary in the sense that they go away when you close them. The Excel Reports button leads to more permanent results, those that are stored in worksheets that can be saved as a file. First, you should realize where these worksheets are placed. This depends on an application setting, which you can set from the Application Settings dialog box from the Utilities dropdown. If the report placement setting is New Workbook, the default setting, these report worksheets are placed in a new workbook. If you would rather have them appended to the workbook containing your model, you can change this setting to Active Workbook. In any case, when you click the Excel Reports button, you see the dialog box shown here, where you can choose from a number of possible reports. However, be aware that most of these reports are versions of reports that you can get elsewhere without risk. Specifically, the Input Results Summary and Output Results Summary options, these two, provide the same reports you see when you click the Summary button. In the same way, detailed statistics, simulation data, sensitivity analysis, and scenarios, these options, provide the same reports you see when you click the 4 small buttons in the results group, these 4. Finally, the model definition options, these 3, provide the same information you see when you click the model window button. For this reason, the option you might prefer is the quick reports option. Still, you have to be careful because this option provides a separate worksheet for each output cell in each simulation. In this case, there would be 123 worksheets in all. That's because there are 41 outputs and 3 simulations. Therefore, I will delete the output ranges as at-risk outputs for the rest of this video and focus only on the NPV output. I can do this most easily from the model window. I will click a range and delete it. I also need to rerun the simulation so that at-risk forgets about the outputs I just deleted. Otherwise, the results are still in memory. Now I will create a quick reports. There are 3 output worksheets for NPV, 1 for each simulation. Each one of them contains 3 graphs. The histogram you've seen, the cumulative ascending version of it, and a tornado graph. This latter graph is discussed in the sensitivity analysis video of the guided tour series, so I will ignore it for now. On the right, you see essentially the same information in numerical form. Another option you might prefer is to use at-risk statistical functions, such as risk mean, risk standard deviation, STD, DEV, risk percentile, and others, to record summary measures directly on your model worksheet. You can see a full list of all such functions in the Simulation Results group under the Insert Function drop-down on the At-Risk ribbon. All of these. Each statistical function takes at least one argument, the output cell being summarized. A few, such as risk percentile and risk target, take a second argument. For a percentile, this would be the probability between 0 and 1. Finally, if you are running multiple simulations, all of these statistical functions accept a last argument, the index of the simulation. Here are a few possibilities. There's risk mean. First argument is NPV. Second argument is the simulation index. I copied that across for the other 2 indexes. Here is risk target, which returns a less than or equal to probability. So the probability less than 0 of NPV for simulation 1. I subtracted it from 1 because I want it greater than 0. Be aware that these statistical functions return wrong values or even errors until you run the simulation. But once you run the simulation, they come alive and show the requested summary measures. If the summary statistics you receive in the reports discussed so far aren't enough for you, you can request a detailed statistics report from the leftmost button below the Define Filters button, this one. This report lists a wide variety of statistics for each output and each input. It also includes a handy section shown here where you can enter target values and see the corresponding percentages at or below the targets. Here I'll try 500,000. Probability of being less than that is about 14%. As with other at-risk report windows, there is a button, in this case the second from the left at the bottom, this one, where you can request that this report be copied to an Excel worksheet. When at-risk runs a simulation, it doesn't just store summary measures of the simulated inputs and outputs. It stores the individual data from each iteration, and it provides access to this data through the Simulation Data button, the X sub I button, below the Define Filters button. This one. Now you see all of the data that was generated. In this case, 5,000 rows because there were 5,000 iterations for the outputs and for the inputs. Again, the second button from the left at the bottom allows you to copy this data to an Excel worksheet, where you can explore the data in any ways you would like. There are a few other report options available in the results group of the at-risk ribbon. These include the Define Filters button, the simulation sensitivities, and the simulation scenarios. However, this video is already long enough, so information about these more advanced options is covered in other videos in the Guided Tour series. A number of the videos in the Guided Tour series have illustrated the many interactive graphs in at-risk: histograms, scatter plots, tornado graphs, and others. Graphs are clearly a very important aspect of at-risk, and there are many ways to change them and interact with them. This video will illustrate some of the possibilities. There are obviously some overlaps here with other videos in the series, but the focus of this video is entirely on at-risk graphs. The model shown here is of a new product introduction. It will be used to illustrate the possibilities. It is adapted from one of the at-risk example files. There are uncertain inputs in the cells with green font, and these lead to the single at-risk output, the NPV of profit, in the maroon font. First, there are graphs of theoretical input distributions. You find these from the Define Distributions button on the at-risk ribbon. In fact, this is often how you enter distribution functions for uncertain inputs. As an example, here is the PERT density for the development cost. This is a continuous distribution, so it is shown here as a smooth curve. As in all at-risk graphs, there are two vertical bars, or sliders, that you can move to see probabilities or percentiles of the distribution. By default, they are set at the 5th and 95th percentiles, but you can move them. Alternatively, you can type values or percentages directly for more precision. All at-risk graph windows have a number of buttons at the bottom. The left 5 buttons are always available: Help, Graph Options, a button for editing or exporting the graph, the type of graph, and a graph overlay. These 2 buttons for zooming in and out are also always available. Now, in a little more detail, this button opens the Graph Options dialog. As in Excel itself, the options are almost limitless. You will probably be perfectly happy with the default options, but you can change them as much or as often as you like. This button provides the following choices. For example, you can create a chart in Excel. It won't be interactive, but you get a picture of it. Or you can copy the graph and then paste it into any other document, like a Word document. This button lets you change the type of the displayed graph. Here are the possibilities. We're currently looking at a probability density. Here is a cumulative ascending distribution, or a cumulative descending, or a relative frequency, like a histogram, where you see bins. Or I'll change it back to probability density and superimpose an ascending cumulative graph. Or get rid of that. This button is for overlaying another distribution on the one you see. For example, I will try a triangular distribution. This is useful for comparing distributions. Or I can get rid of it. The graph of a discrete distribution, such as the distribution of the product lifetime input, is basically the same. The difference is that it has a spike above each possible value, that is the probability of that value. The buttons at the bottom of the window provide the same options as before. Things change slightly when you run a simulation and then look at the distribution of an at-risk output in the Browse Results window, this window right here. There's the NPV of profit. You see the same 7 buttons at the bottom as described earlier. But there are now new ones. Also, 2 of the same buttons work slightly differently. For the graph type, there are now 2 options at the top, probability density and discrete probability. At-risk has some rules for deciding whether an output distribution is continuous or discrete, and it shows the corresponding graph by default, in this case, a density function. It will sometimes decide that the distribution is discrete, and hence display a spiky graph. If you would rather have a smoother graph, you can change the type to probability density. Discrete would look awful here, as I will show you. You can also change in the other direction if you like. Also, the Graph Overlay button now lets you choose an input or output cell for the overlay. For example, here is the NPV density with an overlay of the development cost density. As you can see, they share the same horizontal scale, so it is impossible to gain any insight from this graph. I will clear the overlay. In this case, you can get much more insight from this scatter plot button. When you click it, you can select another input or output cell for a scatter plot. I'll choose development cost. This graph shows a point for each iteration, and the numbers in the red boxes are the percentages of points in each of the 4 quadrants. This particular scatter plot indicates that there is almost no correlation between NPV and the development cost. There are several situations in at-risk where you can see a matrix of scatter plots. One is where you click the tornado button on the at-risk ribbon. Then by clicking the middle button in its bottom row of buttons, you will see a scatter plot of each output versus each of the inputs. Here there's only one output. If there were more outputs, they would be over here. And if you drag one of these, you get a full scatter plot for that particular input versus the output. I'll talk more about that in a minute. A second case where you can get a matrix of scatter plots is when you build correlations into input distributions through the Define Correlations button on the at-risk ribbon. I will do this quickly for a few of the inputs just for illustration. I'll correlate these three inputs. Now they are correlated, and if I run a simulation and then click one of the yellow cells, I get a matrix of scatter plots between the correlated inputs. Again, I can drag any one of those off to blow it up. Now I will get rid of the correlations and rerun the simulation again. Getting back to the output again and exploring the buttons, this button creates a tornado graph. As you can see, there are a lot of options. I will only look at the first one. Tornado graphs are discussed in detail in the sensitivity analysis video in the guided tour series. This particular tornado graph indicates how the mean NPV varies as each of the inputs varies through its distribution. Clearly, the product lifetime has the greatest effect on NPV. A really nice feature of any at-risk tornado graph is that you can drag any of the bars off the window to get a scatter plot of the output versus that input. You saw something like this before. Here, the blue points are for the lower 10 percentile of the input distribution, the product lifetime distribution. The green points are for the upper 10 percentile. And again, the numbers in the boxes show you the percentages of points in each of the four quadrants. Moving on, this button leads to one of two possible types of graphs, a summary trend graph or a summary box plot graph. Each is useful for showing the distribution of an output range, usually a time series range. To see this option, I will temporarily designate the net profit row, row 35, as an at-risk output range. Then I will click this button, click Summary Trend, and highlight my new output range. This is the summary trend graph, or another option is the summary box plot. Each of their legends indicates how each graph shows the mean of the output through time, the yellow line, as well as the variation around the mean at each time point. There are three other buttons at the bottom. This is for analyzing scenarios. This is for creating a filter. And this is for fitting a distribution to the data. There is a separate video devoted to each of these topics in the guided tour series, so I won't discuss them further here. By now you should have an appreciation for the many graph types and graph options available in at-risk. As with many other types of analysis in today's computerized world, an important key to understanding simulation models is visualization. And at-risk does its best to provide you with a variety of insightful visualization tools. This video has certainly not shown all of the options, so don't be afraid to click buttons, drag things, and right-click things. In short, don't be afraid to experiment. You might just happen upon a really nice and insightful graph. In any Excel models where inputs lead to outputs through Excel formulas, Sensitivity analysis is a key aspect of the overall modeling process. Its goals are typically to see how variation in the inputs affects the outputs, and to see which inputs have the largest effects on the outputs. Sensitivity analysis applies to simulation models just as well as it does to other Excel models, and At-Risk provides several tools to implement sensitivity analysis. These tools are illustrated in this video. The model of discounted cash flows you see here is used for illustration. This model is adapted from one of the At-Risk example files. The uncertain inputs appear in green font, and the single at-risk output, NPV, appears in maroon font. Sensitivity analysis can be performed only after a simulation has been run, so the first step is to run the simulation. After running it, you see the distribution of the NPV output. Then a very simple sensitivity analysis is to click the sensitivity button, the one with the icon that looks like a tornado. This provides the following options: 4 possible tornado graphs, a spider graph, and various settings. The purpose of each of the graphs is to show how the NPV varies as the uncertain inputs vary. The first tornado graph option returns the following graph. It shows how the mean NPV varies as each uncertain input varies over its range. The bars are shown in decreasing order of their lengths, from top to bottom, so that the inputs at the top are those with the largest effect on mean NPV. Of course, this shape is where the tornado graph gets its name. Clearly, the annual revenue growth rate has the largest effect. If you would rather see how a percentile of the NPV distribution, rather than the mean, is affected by the inputs, you can choose the Settings option and fill in the dialog box as shown here. Change this to percentile, and change this to the percentile you want. The tornado graph changes as you see. But again, the annual revenue growth rate has by far the greatest effect on the 5th percentile of NPV. For the remaining graphs, I will change the setting back to mean NPV. The other 3 tornado graph options show similar results in slightly different ways. The first option shows the regression coefficients if the 5,000 NPV output values were regressed on the 5,000 sets of input values. For the second option, regression mapped values, the length of each bar is the amount of change in NPV due to a 1 standard deviation change in the input, holding the other inputs constant. The third option, correlation coefficients, shows the Spearman rank correlation coefficients of NPV versus each of the inputs. Finally, the spider graph option provides a line or curve that shows how mean NPV changes as each input varies through its percentiles. Again, this shows that the annual revenue growth rate has the largest effect on mean NPV because its line is the steepest. These same options are available in the summary window by clicking the second button from the left. Also, a tornado graph appears in the Output worksheet when you ask for Quick Reports from the Excel Reports button. Finally, the information is available in a handy interactive format by clicking the Simulation Sensitivities button, again the one with the tornado icon, in the Results group of the At-Risk ribbon. The drop-down lists at the top and the buttons at the bottom provide plenty of options that are quite self-explanatory. For example, the middle button at the bottom, the one that is currently selected, lets you see a scatter plot of NPV versus each of the various inputs. And you can double-click any of these to get a larger view, such as this one. The blue and green coloring is for the lower and upper 10 percentiles of the input variable, and numbers in the colored boxes indicate the percentages of points in the 4 quadrants. This is a lot of information for very little work. Actually, you can create this type of scatter plot directly from any of the tornado graphs discussed earlier. You simply drag any of the bars on the tornado graph off the window, and you automatically get a scatter plot of the output versus that input. There it is. Finally, At-Risk has an Advanced Sensitivity Analysis option under the Advanced Analyses dropdown on its ribbon. When you choose it, you see this dialog box where you can select an output cell to monitor. I will monitor NPV, and you can click Add to add inputs to vary. I will fill in the dialog box for one possible input to vary, the annual revenue growth rate. This is an uncertain input, so its type is distribution. And I will let it vary over 7 representative percentiles. Next, I will fill in the dialog box for another possible input to vary, the discount rate. This is a fixed input, so its type must be cell, and I will let it vary over 7 percentage changes from its base value of 0.12. Once you have added as many inputs to vary as you would like, you can click the Options button to select the graphs and other report options you want. I'll keep those. Then you can click the Analyze button to run the analysis. At-Risk will run a separate simulation for each value of each input being varied. In the present case, there are 7 percentiles for the annual revenue growth rate and 7 percentage changes for the discount rate. So At-Risk will run 14 simulations. For example, for the first 7 simulations, the annual revenue growth rate will be fixed at each of its 7 percentiles. The discount rate will remain at its base value of 0.12, and the simulations will then run as usual. Of course, during these 7 simulations, the other uncertain inputs will vary according to their distributions. After running all of these simulations, At-Risk shows the results in numerical and graphical forms in new worksheets. There are the numbers, and here is the tornado graph. Obviously, the mean NPV is much more sensitive to the annual revenue growth rate than to the discount rate. As this video has shown, sensitivity analysis plays a very important role in At-Risk. Every time you run a simulation, there are handy buttons available to show how sensitive outputs are to various inputs.